Following question is asked from the predicate logic, and from this predicate logic this question was asked for 1 mark. The question is as follows: let P and Q be the following propositions. P is fail grade can be given, Q means student score more than 50 marks. Consider the statement fail grade cannot be given when student score more than 50% mark. This is the statement given to us. Now, which one of the following is the correct representation of above statement in propositional logic? In the propositional logic, which one is the correct statement? So you know that P is there. One statement is P. It is showing fail grade can be given. You can give the fail grade to any student. One more is Q. What it is saying? Student can score more than 50 marks. Student can score more than 50% mark. Right? These are two statements. Now, fail grade cannot be given. What is this? Fail grade cannot be given. Cannot be given means if it is given, it is P. So if it is not given, then negation of P. Negation of P, right or not? What does mean negation of P? It cannot be given. So negation of P will be there. After that, when student score more than 50% marks, means Q is following, right? So if student is scoring more than 50% marks, then fail grade cannot be given, means negation of P. This is the correct propositional logic which is fitting our statement. So if you will see it, if we will try to map it, option A is the correct fit for this statement in the term of propositional logic. Correct? Q followed by negation of P followed by Q. That is the thing, right? Option A. I hope it is clear. This question was asked from propositional logic for 1 mark. So option A is the correct answer. I hope it is clear. The following question was asked from the differentiation, and the 1 mark question it is. If you will see the question, it is very easy question. Very easy question. You can easily solve in 1 or 2 minutes maximum. You only need to know the basic concepts, nothing else. The question is, let fx be a continuous function from real number to real number such that f of x equal to 1 minus f of 2 minus x. Which one of the following option is correct value of f0 to 2 fx of dx? So we are having a continuous function, right? That is from real to real, and the function is given like that: f of x equal to 1 minus function of 2 minus x, right? Now notice this particular continuous function f of x is 1 by 2, right? What this function is 1 by 2, because it is a continuous function from 0 to 2. So if you look at the function, we require a continuous function from real to real. So let f of x equal to 1 by 2. Now differentiating from 0 to 2 for this particular function f of x of dx, it is 0 to 2, 1 by 2 into d of x. I can write it like x by 2, limit is 0 to 2, that is 1, right or not? So what is the correct answer? The correct answer is option B. Very easy question. I hope it is clear. The following question was asked from the matrix, and the question was asked for 1 mark. The question is as follows: let A be the adjacency matrix of a simple undirected graph G. Graph is a simple and undirected, no directions are given. Suppose A is its own inverse. A is its own inverse. Which one of the following statement is always true? A is its own inverse. A equal to A minus 1, like this. A is its own inverse, then which of the statement is always true? Always true. So let A be any adjacent matrix which is simple and undirected. And for a simple undirected matrix, if any matrix is inverse of itself, this only happen if this G is disjoint union of G is disjoint union of K2s, right? So G is a cycle. No. G is a complete graph. No. There is no such graph. No. There may be such graph. G is a perfect matching. Perfect matching. It is the correct answer. Option B is the correct answer for this particular question, which was asked from graph theory for 1 mark. I hope it is clear. The following question was asked from set theory, and the question is asked for 1 mark as a NAT based question, numerical answer type question. The question is as follows. Let P be the partial order defined on the set 1, 2, 3, 4 as follows. That the rule is given P equal to x, x, where x belongs to 1, 2, 3, 4 union 1, 2, 3, 2, 3, 4. This is the rule given on the partial order. The number of total orders on 1, 2, 3, 4 that contain P is. So we need to make a Hasso diagram for it. If you will create a Hasso diagram, then 1, 2, 1, 2, and 3, 2. So let's say it is 3, 3, 2, and 3, 4. 3, 4 is there, right? So this is my Hasso diagram. Now I need to make order, number of total order. Number of total order. So if I will make the number of total order, first order that can be possible is I can go 3, 3 to 1 to 2 to 4. This could be one of the order in which P may contain. The second order that can be there, that is 3 to 1 and 1 to 4 and 4 to 2. The third may be 1 to 3 and 3 to 4 and 4 to 2. And the fourth may be 1 to 3 and 4 to 2. Just making choices from this. And fifth one can be 3 to 4 but 1 to 2, right? So this can be the total order in which we may have these rules satisfied and the Hasso diagram also satisfied and P also contained. So 5 is the correct answer. Total 5 such orders can be possible using this rule on the given set. 5 such partial order can be there. So I hope it is clear. The following question was basically a simple question from you can say that simple of the statistics, simple statistic concept for 2 mark. The question is, let x and y be random variables, not necessarily independent, that take real values in the interval of 0 to 1. Let z equal to x multiply with y, and let the mean value of x, y, and z is represented as x bar, y bar, z bar, respectively. Which one of the following statement is true, right? So I need to make go with one by one. So if you will see here, E of z equal to E of x into E of y plus covariance of x comma y, right? Using this. And if let's say if E of x equal to 1 by 2, and let's say if E of y equal to 1, then covariance of x and y will be 1 by 4. Correct? So in this case, if you will see here, the z bar is greater. The z bar will be greater. So D is not going to be answer for that. Correct. And if you will see that this option A, then it is also not true, because since variables are not necessarily independent, since variables are not necessarily independent, but here if you will see, it may be can cause some kind of dependability, so I can ignore A as well. Now two options are there, B and C option is there, and out of B and C, if we are going to go with covariance of x and y on relationship between x and y, if x and y are proportional covariance, it will be positive. If they are proportional covariance, then it will be positive, else they will be negative. Correct. And it is given that z equal to x comma y, that is x into y. It is already given z equal to x into y, or y can write y equal to z by x, right? So for a particular value of z, if x is going to increase, then y must have to decrease. This makes that x and y are inversely proportional. Getting it? What that makes? That x and y must be inversely proportional. So covariance of x and y must be negative. That is just in B. That covariance of x and y should be negative, and y should be z by x. So option B is following this. Thus option B is the correct answer for this problem, which was asked for 2 mark. I hope it is clear. The following question was asked from graph theory, and the subtopic is spanning tree, and it was asked for 2 mark. The question is as follows: let G be an undirected connected graph in which every edge has a positive integer weight. Suppose that every spanning tree in G has even weight. Which of the following statement is are true for every such graph G? So one thing that we should be very careful is that it is spanning tree. It is about spanning tree. It is not about minimum spanning tree. It is simply a spanning tree, not MST, right? So we only need to be careful about spanning tree options, spanning tree concepts, right? So in every spanning tree, can we say that all edges in J have even weight? No, it does not necessary. Why? One may have odd value, let's say 1, other may have odd value, let's say 3. It could be a part of any minimum spanning tree or any spanning tree, and the result may be even. So it is not necessary. False, right? Then option B, all edges in G have even weight, or all edges in G have odd weight. Not necessary, because let's say these are some of the edges which are odd, and one more edge is there which is even. Again I will get the even result. So it is also not necessary, thus it is also false. Option C, in each cycle C in G, all edges C have even weight. Not necessary. Whether if you have cycle, it depends what graph you are using. So it does not necessary that all edges in C have even weight. Even though if you will make one edge as odd, one more edge is there which is also odd, odd, and then one edge can be there next to it which is even, and we can have a minimum spanning tree or spanning tree from it also, because if there are minimum edges, it might be part of that. Because if you are having 6 edges, let's say it is 7, 6, 5, anything, and these 3 edges are minimum one, so obviously they will be part of a spanning tree, and it have odd and even combination as well. Thus C is also false. So D option, in each class C in G, either all edges C have even weight or all edges C have odd weight. Yes, for each particular cycle we are talking. So in each particular cycle, if each even if every edge have even, then even will be considered, and if every edge have odd, odd will be considered. Else Even order odd even combination will be there, and with the help of that the result may not be even. So conceptually we can say that option D is true. So it is only on spanning tree. You should not be get confused that we are talking about minimum spanning tree. No, not required. We can make a spanning tree for that like this also. Let's say I am not, and one spanning tree that could be like this also. One spanning tree could be like this also. Thing is that we only require spanning tree, not minimum spanning tree. Thus only option D is the correct here. I hope it is clear. The following question was asked from the group discussion, group operation, basic concepts of the algebra, and it was asked for 2 mark. The question was NAT in nature, numerical answer type, and the question is as follows. Let Zn be the group of integer 0 to n minus 1. It means that n numbers we are having here, with addition modulo n as the group operation. The number of elements in the group Z2 into Z3 into Z4 is, that are their own inverse. The number of elements in Z2, Z3, Z4 which are their own inverse, right? So we need to calculate it. For Z2 belongs to 0 comma 1, right? Because n is nothing but number of group integers. So 2 integers are here, 0, 1. And if you will make 0, 1, 0, 1 and plus modulo 2 we are using, plus modulo 2. So it would be 0, 1, 1, 0, right? And self inverse, 0 inverse is 0, 1 inverse is 1. So it is the correct as of now. So we got 2 such entries as of now. What we get? We get just 2 such entries. Now in this particular, we need to consider Z3 also, because we have considered Z2. So in Z3, 0 will be there, 1 will be there, 2 will be there, and modulo 3 will be used here. We need to use the concept of modulo 3. 0, 1, 2, 0, 1, 2. So it would be 0, 1, 2. It would be 1, 2, 0. It would be 2, 0, 1. Just a simple modulo 3 concept. Modulo 3. Because either the remainder will be 0, 1 or 2. That is the thing, right? So here if you will see, only 0 inverse is 0. That is self inverse. But the other one is not like that. Other one is not like that. Because in modulo 3, it is not going to follow 2 inverse or 1 inverse. It is modulo 3 because of that, right? So only one entry we are going to get from here. And one more is left, that is Z4. So this time we are going to have 0, 1, 2, 3. So the remainder could be either 0, either 1, either 2, either 3, nothing else. But modulo is this time 4. What we need to use? We need to use modulo 4. So if modulo 4 is there, then again I will go with 0, 1, 2, 3. Here also 0, 1, 2, 3. So in 0 module 0, 1, 2, 3 as it is. If it is 1, 1 will be there, 2 will be there, 3 will be there, and here it will be 0. If it is 2, 2 will be there, 3 will be there, 0 will be there, 1 will be there. If it is 3, 3 will be there, 0 will be there, 1 will be there, 2 will be there. Just modulo 4. So only whenever it is modulo 4, it is a even. Even means 0 inverse equal to 0, 2 inverse equal to 2. So again we got 2 entries. So Z2 into Z3 into Z4, we got how much entry? 2. How much entry here? 1. How much entry here? 2. 2 into 1 into 2, that is 4. So the correct answer of this problem is, the correct answer of this NAT problem is 4. We are going to get 4 such elements which are going to have their own inverse in Z2, Z3, Z4 for this particular question. 4 is the correct answer. I hope it is clear.